Okay, so as part of our kiln thing, I need this thing to get up to, let's call it 160, or I need to disable the fan and hook it up, hook the heating element to that fan, which can go to 180 degrees F. So let's see what's going on here. Someone said it was based on motor insulation class F limitations of 140. So I googled some stuff. So motor temperature rise equals motor temperature in degrees C minus ambient temperature in degrees C. All right, so this is 70 degrees in my basement, and let's I don't have an infrared thermometer, so let's see. It's like 81, 82, 84. Okay. I got I saw like a 92 in there. All right, so our motor temperature external is 92 minus ambient, so 22 degrees F. 33 minus 21 is 22 degrees C. So it's a temperature rise of 22 degrees C. Say our ambient temperature in the box is gonna be 160. That's 71 degrees C. So 71 plus 22 degrees rise, temperature rise of the motor gives us 93 degrees C, which if I type it in here, says 100, let's call it 200 degrees Fahrenheit. So this is 200 degrees Fahrenheit. So let's just say that 93 degrees C, 200 Fahrenheit is what that motor winding is going to see. Well, that's the surface of the motor. So even if we added another 30 degrees, they said, for internal temperature, let's do that. So let's 93 plus 30 degrees. I read that somewhere. So it's 123 degrees C, which would give us right, 123 degrees C gives us 253 degrees Fahrenheit. Move that up so I can hold it. 253 degrees Fahrenheit is what the internal motor windings would be. So 123 degrees C is where motor winding insulation is a value. All right, so now let's take a look. Add some charts. All right, so even if we said we're class B, I think we're class F. Like 123, I guess, is getting up if it's class B. If it's class F, we're still well in here within the range. Maximum temperature for class F is 155. This is 130. So it could be getting to the limit on a class B, but I think we're class F insulation. I don't know if it's the insulation thing that causes it to be over temped at 140, even a little bit less. All right, so we turn this on and we got the heat coils on, so let's have a look. So we're looking at 312. Okay, the motor now is looking like 230, 250. So maybe the motor's... All right, how about this? Their motor is now like 250 degrees minus 70 air temperature gives us 180 degrees F or 100 degrees C temperature rise. Okay, so for ambient temperature of 160, it's 71 minus the 40 degrees C, which is a class F. All classes are referenced there. So we have to add 31 degrees C to this plus, it doesn't line up where my finger is. So 131 degrees C, which is 267. So we need 130 degrees C insulation, and if we go up to our chart somewhere, let's see, 131, so class B won't do it, but 131 we can get away with class F insulation. 131, 160. I'm thinking like it should be all right. I don't know. I don't know how to do all this fiddling, diddling in numbers, but it's gonna be okay. Unless when we turn both of the heater things on, it gets hotter. All right, so this is on high, so both coils are running. Let's see what's going on. It's like a 426, 427, 433. All right, so let's write that number down. So the coils are up around 430 degrees Fahrenheit. 181, I think that's the motor, 181. All right, so even at the high level, where did I write the number down? When it's on high, the coils are got to 433 degrees Fahrenheit, but the motor, the best I can read, is still about 250. Okay, so let us point out this, I believe, is the over temperature, and this is that is a temperature probe that goes to here. So my thought is I'm going to close it up, put it in the box. We're going to see what the temperature is right at the thermal overload and see what temperature it actually craps out at. Okay, this is what we tied to the heater right by the over temperature limit switch, and this we're going to monitor box temperature, and we set it on low heat, and my interest is to see at what point temperature over temperatures. So let's get a run started, and let's get a run started. Okay, box temperature is 70. My fan is 85. And we're going for power. All That's kind of interesting. Probably because it's moving ambient air next to there. So now that's climbing. Let's move this close. Maybe we can see both of them at the same. We got 75 degrees box temperature. We got 91 the fan. She's climbing quick. We're inside the fan. Box is at 118. Oh no. I have to reset this thing. No, it was only going for so long. Where are we? 123 inside, 122 outside. Kind of interesting how the box and the inside are changing places. The box is like running a little bit warmer than the temperature. Up to 135, still running. And there's a reason for this test. I don't know if I've gotten it this hot before. I didn't disable anything. Yeah, that might smell insulation burning, but I don't. This is crazy. Unfounded. What do we do? Do we let it keep going? It's holding at 145. Well, I guess it's not going to trip. At 145, it didn't trip. I'd have to like up the heater power. All right. Well, we're powering down here. I gotta take a look inside, see what's going on. Okay, I just have it on fan now to cool it down. You can kind of see when I turn the fan on, it really cools it off. But, ladies and gentlemen of the jury, I call your attention to Exhibit A. This was not set at max, so I think that's why it leveled out at 140. What did I say, 145 was it? I think I have to rerun the test with this turned all the way up, but not tonight because it's getting late. I'm tired.